So error output we can put out to the console, or if you're writing command line programs, you can have errors show up in the command line. So if you're writing, especially if you're doing the command line, output using CERR looks exactly the same as output using Cout. There's no difference. And when we used Java, we noticed that when we use system.out.err, all the text that we printed out showed up in red, so that we can distinguish between them. You can't especially if you use the command line. Using C++ programs, output with the CERR appears to work the same as Cout. It does provide a mechanism for distinguishing between regular output and error output. We'll see this later on. We actually won't really use CERR all that much. We will see that they actually go to different streams and they show up in the same area. So Cout and CERR output show up in the same area, but we can actually divert, for example, all the error strings to one file, for example, and the Cout, we can divert all of that to another file. That's called input-output redirection. It's something that we won't use a whole lot of. So for this course, really, there's not a whole lot of difference, but just remember that there is these things are actually different, even though they appear quite similar. Okay, so when we redirect output streams, we can allow Cout and CERR to be redirected to other devices. For example, typically files. We can put all the error messages into one file. We can put all the standard output, meaning the error-free output, I guess, into another file. Or you can have an error console or printers, things like that. I don't think we will be doing much of that this semester, but this is available for you. Okay, input using cin, we've done a little bit of this. The main difference is that you use the extraction operator for cin. So cin works just like system.in. Really the only difference is that we use in C++, we use the extraction operator. It points in the opposite direction. Think of it as pointing towards where the data goes. And also you of course use a different name, use cin rather than cout. These are built in, just like system.in and system.out are sort of predefined in Java programs. So you cannot, of course, you cannot cint into a literal constant like 2. You cannot say cin greater 2, because that 2 is a literal constant. It has to go into a variable. So if you do something like this, cin greater num, this waits on screen for the user to enter something using the keyboard, and once the user hits return, all of these cins, if there's many of them, they all get processed. Okay, so I'm guessing this should be no problem for most of you. When you prompt for input, there's one tiny thing you want to do, which is just that don't put in a new line. So you say enter the number of whatever, and don't use end line or \n, so that when the user types in something, it shows up on the same line. That's all. It's a tiny difference, but it makes your program just that much more user-friendly. Okay, so I would encourage you to try it out if you haven't seen it already in some of the past programs. To be nice to the user, every cin should have a prompt that you print out using cout. It just maximizes your user-friendliness for your program. Other things to think about when you write your program, you want to have good style. In our assignments for this course, you will have to have a header file which is described in the syllabus. The bottom line is you want to make your programs easy to read and modify, especially if I'm grading a lot of programs. I want programs that are easy for me to read. And if you're writing programs for coworkers, you want to make it easy for them to modify your code. So you want comments, you can have the two kinds, the two slashes, just like in Java. You can have the /* ending with a // and both of these are commonly used. I would say do the kind, whatever you've been doing before probably is fine. If you're ever in doubt, just check with me. There is no Javadoc style comments like you get in Java. In Java, you can have a /*, and that's a special comment that's sort of extracted by the Javadoc program. There's no such thing in C++. Nothing standard in C++. As far as style goes, if you have constants, remember in Java they are finals. In C++, they are consts, C-O-N-S-T-S. Use all caps for constants. You can use lower and uppercase to use uppercase to separate sort of English words within a variable. Maybe rather than, in some cases it's useful to have underscores, so you can put a lower _to upper if you want. Either one is good. I think in general most people prefer this style without the underscores, but use underscores if that's something you like. But the most important thing is you want to have meaningful names that make it easy for people to read your code, so that maybe you don't even need that many comments. If you use meaningful names, your code will be that much easier to read, and maybe use fewer comments. Okay, a word about libraries. We will be using a few libraries, but the main thing right now is just IOStream. So there's a whole bunch of C++ standard libraries. Later on, we will use quite a few. If you're taking the Linux course, you will probably use a lot of libraries, probably more than we will in this course, in the C++ course. The way to use them is in C++, you say #include, and then in angle brackets, the name of the library. So this is different from C. In the case of C, you have to use angle brackets and library name .h. If you ever see a #include with angle brackets and just library name without .h, chances are good you're using C style libraries as opposed to C. I'm sorry. Let me repeat that. I think I said the wrong thing. If you see a #include with angle brackets and you see something without a .h, you're using C++ style libraries and not C libraries, because in C we pretty much always have to have the .h, and that's just the name of the file. So once again, if you see in angle brackets, if you don't see a .h, C++. These are preprocessor directives. That is, before the compiler actually runs, a preprocessor processes your source code. So when you compile something, even though you use G++, actually what happens is a preprocessor runs before the compiler and does some manipulations. We'll see more of these later. In the case of library files, all it really does is it finds this library file, and it's actually a .h file, and creates a temporary file with a copy of the library file and your code sort of merged together. And so that's what the preprocessor does. And there's other things that we can do with preprocessors, something that we will see more of soon. C++ has many libraries for math, for strings, and all that. Strings is probably the first one that we'll encounter after IOStream. We've already done input-output using IOStream. Namespaces we'll see in more detail later. What it is a way to avoid this thing called name pollution. That is, you say that names only have meaning in this one namespace, so that you don't have a lot. If you use, for example, iostream.h, you don't automatically get all of the names that are defined in this IO stream. You have to use the statement called using namespace std. This says there is a standard namespace that's defined in IO stream, and so what this allows us to do is, rather than use variables like C, if you did not have using namespace std, you would have to use things like this, std : cin, and this : is called a scope resolution operator. It says that look inside this namespace, and this namespace is called standard or std, and inside that namespace you should see a name called cin. And so once we start, if you can do this, you can always use the full name, just like in Java. You can use, for example, print stream dot whatever, or java x dot swing, for example. You can use java x dot swing dot jbutton. Rather than using that, if you import java x dot swing, then you can just use jbutton instead of java x dot swing dot jbutton. Same idea here. You're importing names from this namespace. And in effect, these two statements together allow you to use cin and not use std : cin, or std : cr, or std : endl, and so many other things. Okay, so what it comes down to is this makes our code a little bit easier to read sometimes, and also keeps namespaces separate. If you see a lot of using namespaces, that's probably not a good idea. But however, this is okay, because everybody uses it in C++, and so that is fine. If you see a whole bunch of using namespace, whatever, one after another, you might be asking for trouble, because it's going to make your code a little bit hard to figure out.